In today's discussion, we're going to discuss about two main topics in the Python, which is decorator and generators. The first one we're going to do is decorators, and later we're going to jump into generators. Right? So before directly jumping into decorators, there is a concept of function aliasing. There is a concept of, so the concept of function aliasing, how this works is, you declare a function. So for example, I'm taking a function, which is add function. Okay. So which is the simple one. So everybody can easily understand. So it's a def of declaration of the add function a comma b, and it is going to return you the sum of a plus b. Okay. This is a normal way of declaring a function, right? What I am doing now is I'm taking this function, assigning to a variable. Assigning to a variable. This is going to be my new underscore add, my new add function. I'm doing this as a function aliasing. This is what we call function aliasing. Okay. Let's execute this. Done. Now, if you want to execute this piece of code, either you can call with a new add, either you can call with add. Let me show you how it does. Done. Add. We're taking two arguments, 10, 20. The result should be what? 30. The same thing can be achieved by calling with a new add, new underscore. Okay, same result, 10, 20. Got it? Function aliasing works in a way. You are just declaring a function, and the declared function is assigned to different variable. Same going forward, you can use either of the names to call and execute that function. It's a simple statement. The way you are doing your variable declaration, you're gonna do the same thing here. Got it? So in this behavior, if you want to check whether what is the address is, I declared a function and I'm aliasing it, that is fine. Then how about what are the addresses? What are the addresses it is storing? I'm telling you, it is referring to the same statement, same function itself. How you can verify it. Verification is also important. So how you can do this? Use address to verify it. For example, if two people living in the same city or same village, you can ask which village you are staying in, right? Once they say what is the address of them, so it is easier for you to identify, right? A similar way, we're going to use address. How are you going to check the address? Use ID function. Use ID function to get the address of this ad. Simple. This is the address of this ad. Let's get the address of this new ad. Got it? So if you see these addresses, both are same. Both are same. If you still, sir, I didn't count it, just do address comparison. That's it. ID of ad. This is equal to ID of new ad. If you're getting it true now, so you're having the same address. Otherwise, it's a different address. See, you're getting it true, which means that both functions are pointing to the same function. This is the concept of functional aliasing. It's a very simple concept, but it plays a very vital role when you are doing programming and when you are doing unit testing with the PyTest. This is there is a multiple use cases, and we'll go by in the upcoming sessions. So for now, just understand the way function aliasing happens is you take the function name and assign it to a different variable. What you do as part of function aliasing, take a function name, assign to a variable. Got it? So that is function aliasing. In function aliasing, as an extension of function aliasing, we have a small concept that is monkey patching. We have called it what? Monkey patching. concept of monkey patching. Sir, what is monkey patching? It's the same behavior, the same what you are doing with the function aliasing, right? The same thing you do in the monkey patching also. So what monkey patching does is changing the behavior of a method or a function. It can be anything at runtime. Okay, this is called monkey patching. Okay. So let me give you a quick example so you can easily understand what this statement is. So what monkey patching is, you have just declared a function. Okay, that function is behavior is getting changes at the runtime. Let me show you for this example. I'm having def. Let's take a quick example. So we're gonna greet. Okay. So this greet function, what it does is it's gonna return you, or either it's gonna print you what? Good morning. So it's a greeting, right? I'm declaring another function, wishes. It's like birthday wishes. You're saying print happy birthday. I'm having two different functions. Each functions are different. If you see here, when you call a greet function, it's a greet. It's like good morning will be printed. Simple. When you're having a wish function, you're just getting happy birthday. Now, what I am going to do is, I'm going to change the behavior of wish with a greet. What I'm doing is, I'm doing a function aliasing. I'll do function aliasing. So I'm going to assign greet. I'm going to assign greet to the wish. Take wish, assign this greet to wish. So now going forward, there will no be wishes. You will always get good morning. That's what I told you, right? What we are doing, this is what we call functional aliasing. I'm changing the behavior of a method. So going forward, when I call this wish, it will not give me happy birthday. It will give me good morning itself. When I call greet, I'll get good morning itself. The connection with this function is gone. I'm changing the behavior of a wish. What this wish is doing is going to say happy birthday. Now later, once I'm changing the behavior, it is no longer say happy birthday. It's going to say you good morning. This behavior is called monkey patching. You're changing the behavior of a method or a function. Okay, so let's execute this. Now functional aliasing is done. Okay, so what I'm going to do is just call this greet. What you get? Good morning. If I call this wish, if this functional aliasing is not done, what I would be getting it? Happy birthday, just like here, right? Since I have done a functional aliasing, see here what happens. You'll get good morning. I change the behavior of wish function to the greet. So no longer it is referring to the wish. It is all even you are calling a wish function, this will always refer to what? Greet. Let me show you a big difference. The way I'm giving you address, right? Let's compare that. So you'll have differentiate more examples to differentiate. Let's re-execute this from beginning. Okay, so I'm having my greet. This will be good morning. Now I'm having wish. I'm having my happy birthday. What I'll be doing is just take ID, address of greet. Okay, address of greet. All this. Got it? So let's get the address of wish. Both are different. Just observe the last three digits. It's a 088, it's a 496. So there is difference. Once I'm doing this function aliasing, the behavior changes. Now you're gonna get a good morning itself. When you call a wish also, you'll get a good morning itself. Got it? So now let's do the address verification. ID of breed, ID of fish. So it's ID. Yes. See here, both are referring to the same address. This behavior, changing the method behavior at the runtime, is called monkey patching. Understood?
Yes.
Yeah. So let's move on to the next topic, which is decorators. Okay. So what decorator means? A decorator is the process of adding additional functionality to the existing function. A function should be existed, and you are just adding additional functionality to it instead of directly modifying that function. So, for example, take this scenario. Okay, when you are working in a real-time projects, you declare a function, and that function will have a specific behavior, and this being uses at 5 places. Okay, so now what I am my requirement is among these 5 places, there is one specific place I want to add additional functionality. I want to add some more functionality to it, but that is not required for the remaining 4 places. Following, having a function name. Okay, this function is used 5 different locations. Out of this, in one location, I need extra, no additional functionality. But this is not required in where? Not required for remaining 4. Not required for remaining 4. Okay. So what I can do you I cannot go ahead and create a new function for it. But like there, it will be like duplication of the method. That's it. Okay. For only one function, I need other no additional functionality. For the remaining 4 locations, I don't need it. In that case, we're gonna go with decorators. We'll implement the decorator. Okay. I will add this decorator to this one single location. The remaining 4 can be as it is, but for only one this location, we'll add this decorator. You want additional functionality, right? Okay, let me create a decorator for you and let me add this functionality to this single location. And wherever you want it, just add this decorator. That's it. It will take care of it. Okay, so if the remaining 3 locations or 4 locations is not required, yeah, you can ignore it. There's no problem. All what what I'm gonna do is that is all I'm gonna do. The normal way of creating a decorator, the syntax will be the syntax decorator, or you're going to declare a decorator def. Okay, you're going to have your decorator. You can give any name. This decorator, you can give any name. And this takes a function as an input argument. What it will take? A function. Everywhere you are passing variables or any arguments, that is all you're going to do. But this is the only place you pass a function as an input argument. Got it? So in order to add additional functionality to it, right? And which function you want to add additional functionality? So that is the reason I'm going to take function as an input argument. Okay. This is going to be your decorator. Later, this is going to be your wrapper. You are taking this wrapper and adding to this location. That single location. Okay. I'm taking this wrapper. This is going to take your arguments. But this function, what are the arguments you need? You'll just pass these arguments to this. It will accept it. Just return this function with this argument. And finally, you return that function. At one go, you'll not understand this, but I'm giving you more examples so you'll understand more. For now, let me give you a different example so you can understand this syntax. You can understand the syntax. For first thing, I'm giving a division decorator as the function. You can give anything. No need to be the same thing. You can give anything as a function. What is the input argument? It should be always a function. A function will be always an input argument for your decorator. Like this. Let's wrap it up. What is the wrap up? Okay. Let's just do this. Arguments. Okay. Return the function with args. Then the wrapper. Simple. So for reference, let me give you one print statement so you'll understand whether it is executing or not getting executed. Okay. Inside of the wrapper. Good. So let's execute this one. Okay. So my decorator is ready. My decorator is ready. You have to add this decorator to a function. You have to add this decorator to a function. How you will do is you use @ to add a decorator. Okay. So before adding this decorator, you have to declare a function, right? For the function, you are adding this behavior. That function is going to be def of division. It's going to take how many arguments? A comma B, 2 arguments. And return repeat. My another function is also ready. Then just do division. Pass 2 arguments, then comma 2. You will get the result was 5.0. Because you are doing division operator, not a floor division. Division always give you 14-point results. Okay. So for this division function, I am going to apply my decorator. For this division function, I'm going to apply my decorator. How I will do it? You have to do what? Taking new line, add this @ add use @. What is the decorator name? This is the division decorator, right? Yeah, just add this. That's it. Done. Okay. But there's a small mistake here. Always remember, the function is taking how many arguments? A comma B, 2 arguments, right? You have to pass 2 arguments here. For this function, the function we are applying this decorator, right? If it is taking how many arguments? Based on those arguments, you have to pass those many number of arguments. You have to pass A comma B. Here also, once you change there, you have to pass A comma B. Then only it will work. For example, I didn't change. For example, I didn't change. And I simply run this again. Let's assign this again. Okay. When I'm executing this function, you'll see like it is expecting 2 arguments. Okay, it is expecting only 1 argument, but 2 was given. Like that, it will get. See here what happens. It definitely will get error. See here, it is expecting 1 argument, but 2 was given. Got it? The problem is, as I mentioned earlier, for this function, how many arguments is taking? 2 arguments. Arguments here. No need to be an args. Okay, it can give. Not need to be an A comma B. You can give X comma Y also. This is the function arguments. You can change it. Just add X comma Y. That's it. Okay. So once you change this, let's rerun this one. So let's apply this. Run now. So definitely you'll get what inside of wrapper. See here. Once I applied this decorator, what is happening? It is inside of a wrapper. Then it is giving me 5.0. Observe the behavior here. When you are using the decorators, behavior is going to be very important. The behavior is going to be very important. Always remember, when you are apply a decorator, then you apply a decorator to any function, the execution control first will go to decorator. First, it will go to decorator. It will come to function. If you don't know, let me give you more reference. Here you add another print statement inside of division. Let's do this as a variable result. Wrapper is done. And finally, return the result. Okay. So let's give you this example. See here, when I'm calling this function, right? The first control goes to decorator, because when you're calling this function, it will come and see this function. This function is associated with what? A decorator. Okay, let me go to the decorator. Okay, fine. I'm having inside of it. No, I'm going the decorator. I'm going to the decorator inside. First, what is the statement? Inside of wrapper. Inside of wrapper. First, it will print inside of wrapper. Then what is the next statement? Function call. What is the function? You're calling this function, right? This function is taking 2 arguments. This 2 arguments is given. Yes, 10, 2. 2 arguments is given. Done. Then the result will be, it will come here. Wrapper is done. Wrapper is done. But before wrapper is done, if you see here, there is a print statement in your division also. There is a print statement in your division also. First, it will print inside of wrapper. It goes inside of a function. Inside of a function, there is another print statement. First, it will print what? First, it will come and print inside of wrapper. This is fine. First control. What is the next control? It goes inside of a function. Inside of a function, there is a print statement. Yeah, there is a print statement inside of division. Okay. Later, what I'm doing, I'm just returning it. I return the return value is stored in result. Okay, it is result. Fine. So what is the next statement? The wrapper is done. Next, I'm having another print statement. The wrapper is done. So got it. Okay. Finally, what is the result? I'm going to returning it. I'm returning 5.0. Last, you'll get 5.0. This much will happen once you line execute this line. These 4 lines will be printed once you do this line execution set. See here. Inside of a wrapper, inside of a division, wrapper is done 5.0. Cool. Let me walk you through in a visualizer. So you'll have line by line comparison. So my decorator is ready. Let's take my function. Okay. And let's call this function division of 10, 10, 4. It's up to you. See here the execution flow. When you are using a decorator, 2 things is main important. Always remember 2 things very important. First one is, what is the behavior you are adding it? The first thing you should know, right? Why you are adding this decorator? Why you are adding it? Once you know why, then go and add this functionality. Once that is done, you should understand the execution flow. Which one is getting executed first, which is getting executed later. Once you understand these 2 things, we are done with the decorators. It is a very simple and small topic, but people will make it as more complex. Okay, don't go with that complex nature. I'll make it more and more simple. Got it? So you're just taking a function, and this function you are adding some additional functionality to it. That's it. How you are adding this functionality? You are just using a decorator. In this decorator, you're having a decorator name, and you are having a wrapper. You are applying this wrapper to your decorator. Got it? So for this wrapper, it is taking 2 arguments. Why it is taking 2 arguments? Because the function, it is this wrapper is applied to. This wrapper is applied to a function, right? That's what I told you. If this function is if this wrapper is getting applied to this function, this wrapper is getting applied to this function. How many arguments it is taking? 2 arguments. Pass those 2 arguments. That's it. With these 2 arguments, you can play with this data. That's it. Got it? So let me show you how it is execution flow. See here, there is a def. That's it. There is a decorator. It didn't even went inside. Now I'm having my division decorator. Once you call this division decorator, at the time of loading, it will just reference it. See here. That's it. Okay. For a division function, there is a decorator is applied. There is decorator is applied. What is the function? What is the function? It's a division function. For this division function, there is a decorator which is applied. What is the decorator? Division decorator. Okay. So let's jump in. That's it. But if you see here, these lines is not get executed. It is just referencing it. It is storing in the memory. When you are using the calling this decorator, it should be able to point out, right? It is just loaded into all this data is loaded into memory now. Okay. So my division is done. Once this line number 17 get executed, then only the control goes to line number 3. Let me go to the first statement. See here, see here, from this control, line number 1 to line number 11 directly. Got it? So, but I'm having a division function. This division function is applied with a decorator. That is the details you're gonna store. See here. But this division decorator, what is the wrapper? I told you, right? There is a wrapper. This wrapper is getting applied to this function behavior. I'm storing this wrapper details also. Okay. That is what is stored. But line number 3 never got executed. Control come to line number 70. When I'm calling this division function, I'm calling this division function. See here, it not even go to line number 13. It will go to decorator itself. See here, it directly went to decorator. See here, from division function, it didn't even call it. It will not even go to inside of this. Directly, it will go to decorator. See, understood? For this wrapper function, how many arguments it is there? X comma y, 2 arguments. 2 arguments passed. So otherwise, you'll get what? Argument error. You are given, no, it is expecting 1 argument, but 2 was given. Okay. So now, next. What is the first statement inside of wrapper? Then let's execute the function. What is the function? Division function. It will come and execute inside of division. See here. Now it will come inside of division. It will print inside of division. Got it? So it is written. What is the next statement? Wrapper is done. Okay. So now next. That's it. Okay. So we are done with the steps. Sir, I didn't get 5.0 because you didn't get the 5.0 because you didn't keep this one in a print statement. If you kept it in a print statement, it is coming. So then why it is coming in the Jupyter notebook? Jupyter notebook by default, the last executed statement will be printed. Okay, so we don't want all this confusion. Let's just keep it instead of a print. So you can see the result. Just visualize it. Just directly go to the last step. We got your 2.0 because you are doing 10 divided by 5. The result will be 2.0. Simple. I'm okay with this. I'm okay with the decorator. For this division decorator, right? Let's add more functionality to it. Let's add more functionality. Like this is advanced. As of now, we are going for beginning only. We are going next step, which is the advanced step. Let's take this decorator. Good. And let's take this function. Let's call this out. Okay, this is just add 1 1. So you can differentiate division decorator 1. I'm not executing the previous one itself. I'm just change the decorator name, function name. I changed it. So let's change here also. Okay, let's rerun this one, this one, this one. Look at the same result. Okay, now I'm gonna change the behavior. I'm gonna just add some more behaviors to this. What I'm doing is division 1, 10, 0. I'm doing 10, 0. What will happen? Zero division error. You guys are not practicing. You'll get zero division error because you're dividing with it 0. Okay, and I have shown you example how you can solve this kind of thing with exception handling. Do practice. Okay, so here, when I'm doing this division decorator, right? I'm taking two arguments, x comma y, right? What I'll do is, before even executing this function, I'll stop the program execution. I'll stop the program execution if the y is equal to 0. When you're having a numerator, denominator, when you're doing a division, upper variable is called numerator, below variable is called denominator. If my b is equal to 0, I'm gonna return simple. Say that cannot do division here. Okay. So what I'll do is inside of a wrapper, if my y, the same thing. If you are confused, let's go with the same naming convention. So a, b. This is a, and this is b. Okay. If my b is equal to 0, okay, print you are dividing with 0. You are dividing with 0. You will get it. You will not get result. Not get the result. And simply return nothing. I'm simply not returning anything. This is done. This is possible. Okay, I'm simply not returning anything. Or if you want to return anything, also you can return it. But when you're dividing with the 0, you will not get any result, right? So I'm just resetting empty. See here how this changes. I'm not doing any exception handling here. I'm handling this thing with the decorator itself. Okay, let's re-execute this. And let's re-execute this one. Now this decorator behavior is added to here. But you should give what? 1. Should give 1. It's still referring to the old one. Okay. So now this new one is applied. Okay. So now let's re-execute this. Since we are doing 10, 2, there is no errors. Now when I'm doing 10, 0, see here. If my execution flow is correct, what it should do is it will print inside of wrapper. Now b value is equal to 0. You are dividing with a 0, you will not get the result. That's it. You should not get any zero division errors, no other result. You are simply returning here itself. The remaining piece of code will not get executed. Once name function, just try this. Inside of a function, we add a return. After return statement, add some more lines. Those lines never get executed. Okay, see here what happens. Let's execute this. See here. Now my zero division error is gone. My zero division error is gone. How I handle How did I handle it? Using decorator. I'm not using any exception handling here. I'm not using any exception handling. With the decorator itself, I'm handling this. This is the advantages of the decorators. Okay. So I'll give you one last real-time example, which we most commonly uses in a real time. Okay. With that, we'll wind up with the decorators. So we can move on to the next topic, generator. Okay. So the most real-time example is timer. It's a timer. Because if a function is taking more time to execute that function, okay, I need to know how much time it is getting, how much time it is taking to get executed. Got it? So I want to know each function, how much time it is taking to execute. How much time it is taking to execute. Right? So now, for that, how I go to implementation is add timer decorator. I'll use timer decorator. How we will do timer decorator is, let me, I'm giving a real-time example. You have to do timer import. Because you want to do the time calculation, right? How much time it is taking. You want to do time calculation, you need time, right? That time is available in time decorator, no time module. Just execute this. I'm declaring a timer decorator, f of timer. This is my timer. For this timer, all this function as an input argument, f of tapper. These two statements very fast. Okay, if your function taking any arguments, you can pass it. If it is not taking anything, just leave it as it is. And you don't know, okay, you don't know whether it is going to take an argument or not, just add args and quads to it. Just add args and quads. So this becomes optional parameters. This become optional parameters. It is up to you whether you want to pass an arguments or not passing an argument. But this thing will be make your arguments optional. Okay, sorry for that. Where is it? Okay. So I'm having my timer decorator. On timer decorator, you are applying this function, right? And this is a very generic function. This timer is a very generic function. And you might not be knowing how many arguments it is taking. In these previous examples, I'm applying this decorator to this function. It is taking how many arguments? 2 arguments. I pass 2 arguments, right? But if you are familiar with these args and quarks, which I explained in functions, there is a 4 different type of arguments: position arguments, keyword arguments, default arguments. This is what? Variable length arguments. Yeah, very good. So even you are passing 0 arguments is also okay. If you are passing 100 arguments also okay. So that is the reason we go with args and paths to make it more generic. Got it? And let's call this timer. What is the starting time? What is the starting time? Time dot time. So start with the time now. You started the timer. It's just a stopwatch. Just stopped and stop. You're gonna start it and you're gonna stop it. Right? Once you started, let's call the function and pass this args and plots. These are the input arguments for what? Input arguments for your function, right? You just pass them. Same way here, what you're doing. You're just doing a comma b, right? And you are passing those arguments to your function. Same thing you are doing args and quads. Don't get confused when it comes to args and quads. That is the reason I didn't directly jump into here. Take a smaller one. I'm giving you step by step here. Here, for this function, it is expecting 2 arguments, right? For those 2 arguments, you're passing here. When in case of generic, You don't know how many number of arguments, right? Okay. This many number of arguments, you are just passing it. Once that is done, you need end time. Let's get execute this function. Okay. That function to be executed, you're gonna calculate ending time. Time dot time. That's it. This is your end time. This is your starting time. This is a stopwatch. It's a timer. Once this entire thing is done, just print it out. How are you gonna do it? For function, for function to execute. It took how much time? How you do calculation? End time minus start time. That's it. So when you're doing a stopwatch, right? How you'll do? You differentiate what is the ending time with the starting time. So you'll get those seconds, right? How much time it took. So that's what you do. Right? Our decorator timer functionality is done. And finally, what you have to do? You have to return the wrapper, right? You have to return the wrapper. That's it. That is all. It is gonna take. My timer is ready. My timer is ready. Let's add a quick example of some different functions. It is taking the add function, a comma b, return a plus b. Okay, let's add subtraction. That is a comma b. But this time, what I'm gonna do is directly doing the subtraction. I'm gonna sleep for time. Time dot sleep. I'm gonna sleep for 5 seconds. I'm gonna sleep for 5 seconds. I'll not do the execution. Now finally, I'll do a minus b. My functions are ready. My functions are ready. And I'm going to take this timer and apply it to these functions. I'm going to take this timer and apply this to functions. How I'll do it? Use the rate. Use the rate, add timer. And finally, this one also. Just the rate. Okay, let's rerun this too. Okay, let's once your function is ready, your decorator is ready, you apply this time decorator to your function, everything is ready. Now let's start the behavior. Let's call this add. Add method 10 comma 5. What should be the result? 10 comma 5. Result will be 15. You are doing adding, right? If there is no errors, you should get the result 15. But before 15, you will get this statement. This statement. What it will say? For function to execute, it took how much time? Okay. So here, if you observe, I'm not returning this function. I took the result, right? I have to take this result and I have to return it. If you don't return it, you will just not get anything. So that is the reason you're not getting anything. You have to do return statement, return the result. Got it? Just execute this one. Let's reapply to this too. Now do add. Yeah, see here, my 15 is coming. Earlier it is not coming because I forgot to return the result. Okay. If you observe how much time it took, it is in minus. It is in minus. It took this much time to execute. It is in fractions of seconds it took to execute. Okay, but when I'm doing the subtraction, right? Let's do the subtraction. 10, 5. You'll get the result 5. But see here, it is gonna sleep for 5 seconds. It is gonna sleep for 5 seconds. In this case, it took microseconds to execute, but this case, it will take 5, minimum 5 seconds, minimum 5 seconds. See here. See here, it is sleeping. See here, it took 5 seconds plus some, some milliseconds. It took 5 seconds plus some milliseconds because you went for sleep, right? This function, it slept for 5 seconds. So that is the reason. Let's re-execute this. See, it's taking time to execute because it is in sleep mode. And finally got the result. Got it? So there is one last thing I want to tell you. See here, if you see here, it's a very generic statement. For function to execute, how much time it took. For function, this much time it took. This is a very generic statement. I don't want a generic statement. I want to know for which function exactly. For which function exactly, how much time it is taking. Instead of giving just for function, just give me for add function to execute it this much time. For subtraction function, it took this much time. How you will do it? For that, it is a small thing. Just remove this. Just put it in your curly brackets. What you're taking function as an input argument, right? Just give that function. Put dot, give double underscore name. That's it. The job is done. That's a very simple word. This will carry every function. This is passing as a generic function, right? The generic function will have a name. It is going to take that name. That's it. It is going to take that name. Once I added this, let's reapply these two behaviors. If you observe now, earlier case for function to execute, now it will get for add to execute. See, for add to execute. So now it is very easy for me to understand. Otherwise, if you say for add function, you can give anything. It is up to you. It's just a print statement. Okay, so let's reapply this to again. See, for add function to execute, it took this much time. For subtraction function, let's do this. It is sleeping for 5 seconds, right? Let's wait for 5 seconds. See here, for subtraction function to execute, it took 5 some seconds. So this is a wonderful functionality because every time there is a few functions, it will take longer period of time. When you are making an API calls, when you are doing database insertions, when you are doing a file handling, when you are having a millions of records, right? And you want to calculate for those many number of seconds, for those many number of records, how much time it is taking, right? You can apply the time decorator so you can find it, how much time it is taking. Okay, that is all. So, any doubts? Tomorrow I'll explain the decorator chaining and then we'll go to the generators. That is all tomorrow. For now, please practice this. Once you listen the class and once you practice immediately, so you'll remember. If you missed 1 or 2 days, later you are coming back, you will not understand. You'll have to go through the recording again. Okay. Any doubts or any questions?
No, sir.
That is all. Have a good day.
Thank you, sir.